let's look into this concept about the area. I've mentioned it in the last few videos when we're talking about integration. And there's different ways to phrase this. You know how when we talk to each other or you talk to a friend, maybe you text them. Um, I don't think people write too many letters these days, but when you're communicating with a friend or a peer or someone that that you just barely know, maybe you um, use a different voice, a different set of um, punctuation and grammar and things than what you would write if you were, say, writing for your English teacher for a grade or writing in a professional setting for your boss or a publication. You can see that there's sort of like the everyday language, and then there's the proper, more formal, more businesslike, more professional sounding voice that we would use in a professional communication. So sometimes people just say, find the area under the curve. Well, okay, you kind of need to know a little bit more information because typically when they say find the area, it means the area between the curve and the x-axis, which is where y is equal to 0. Um, as you go farther along in the calculus, though, we're going to find areas between two curves or between um, several different locations. They use different ways to describe it, some more formal than others. Okay, so but the key here is if they say to find the area, I'm going to compare and kind of contrast here the right way and the wrong way to do this. Okay, so let's start off with the right way. Okay, so if they say find the area between the function f of x, and I put this in factored form because there's a couple of things I need to point out. Typically, they would not already have it factored out. It might have shown up as the negative of x squared plus 7x plus 10, and you would have had to factor it. All right, but for the purposes of what we're doing, I've factored it out for you. But find the area between this function and the x-axis. Now, let's look at the function. All right, so if you have it already factored, your x-intercepts here would be at negative 2, 0 and negative 5, 0. So over here's negative 2, 0. Here's negative 5, 0. Now, if it says find the area between this function and the x-axis, well, okay. Now, there's some alternatives here, right? We could find this area right there. We could find the area between this x-axis and this part of it. You would not find the area there because it's not bounded, right? It's not enclosed. This is sort of enclosed. This you can see leads very quickly to, wait, where exactly are you talking about? But if they say find the area between this and the x-axis on the interval from negative 5 to negative 2, then that gives you the information you might need. So here's negative 5, here's negative 2. So we want the area between this curve and the x-axis. So we're looking at this area right there. Okay. Now, as we mentioned in an earlier video, if you're finding the Riemann curve area, you've got a bunch of little bitty tiny rectangles. You could also find the Riemann sum for down here, but the heights going down this direction, these would be negative y values, and these are positive y values. So when you multiply the little bases of your rectangles times your heights, up here you're going to get a positive area. And down here in this section, you would have a negative area, right? And when they talk to you about the area, it's assumed that they're wanting an area as in like you were going to paint it or put carpet down on it. So they don't want negative areas. They want to say, okay, if I was going to buy carpet to lay down in that area, I don't care if it's on the above the x-axis or below the x-axis. I just need an area. Okay. So when they talk area, you have to be careful. As soon as they say that word that says, I better graph this, right? Because what you're looking for is it positive in that section or negative in that section? Because they want positive numbers. If they just ask you to integrate it, if they just say, integrate this from -5 to -2, dx, then they're not saying anything about the area. If they just ask you to perform this function and just integrate it, then you just come up with a way to integrate this. You would need to multiply it out and say it's the negative of x squared plus 7x plus 10. And then you would add 1 to the power divided by the new power. And regardless of whether it's above the x-axis or below the x-axis, you would just integrate it straight from -5 to -2, right? But once they say find the area, that means, all right, if I had started here, I would have to factor this out and find the x-intercepts. I would maybe have to conceivably use synthetic division to find where it's located. Use your graphing calculator, whatever your teacher lets you use. But as soon as they say the word area, the first thing on your list of what to do for this is say area, decide if it's above the x-axis or below the x-axis. All right. So this one, I want the area, and I look and go, oh, thank goodness. Here's -5, here's -2. All of that section is above the x-axis, so I'm good. I can just integrate straight from -5 to -2. Now what I can do is pull this negative out so I don't have to deal with it. Okay. And then I would add 1 to the power and divide by the new power. And evaluate it from -5 to -2. So then you would put in your -2. Be careful with your positives and negatives. So where a lot of the errors are. Then you're going to subtract. And this is where even more of them are. So this would be the negative. And when you clean this up, you'd have -8/3 plus 28/2 minus 20 plus 125/3 minus 175/2 plus 50. Now, a lot of students have become completely dependent on their graphing calculator or their calculator. Again, I don't know what your teacher is going to allow you to do. And sometimes you have to do this math when you don't have access to a calculator. And so you just need to know how to do it by hand, right? So one of the things that you learn to do if you have not learned this because you had a mechanical device is you would go, okay, here's thirds and here's thirds. So I can combine those. That's why you don't necessarily clean them up as you go. And you'd have 117/3. So in other words, don't change -8/3 to a decimal or something. Just see if you've got like pairs and combine those first. And then 28/2 and -175/2 are like denominators. And then -20 and plus 50 or 30. And then, if you're still doing these by hand, and I did this by hand, so we're going to work this all out. All right, it's 234/6 minus 441/6 plus 180/6. So this is the negative of a -27/6, so that you can see how the signs work. All right. Now, as you can tell, if you lost a sign as you went along and somehow this became positive right there, you would end up with a negative number, and that right there is a clue that something went wrong. So if it asks you to find the area, not just to integrate it, okay, but just to find the area, and you come up with a negative number, something happened incorrectly in your math. Okay, go back and find it. Go back and fix it. Maybe it was the fact that you didn't realize that it was below the x-axis. Maybe it was a lost sign. But if it turns out to be negative, something's wrong. So this is 27 over 6. And just so we can get a reference point, this is give or take about 4.5. So this is the area, 27 over 6 square units. All right. In this particular case, if you had not graphed it and you had just gone, didn't even notice that this was round. If you had just gone ahead and integrated it straight from -5 to -2, you would have been accidentally correct. Now, what are the odds that when your teacher makes up your test or chooses your homework, that they're going to come up with a problem that you can do incorrectly and be accidentally correct? I don't know any experienced teachers that let you do that. Okay, maybe if it's their first semester teaching and they haven't figured that part out yet, um, but usually not. Okay, I would even say first year teachers are looking out for that too. But after you've taught for a while, this isn't going to happen, right? So don't count on being accidentally correct. Now, I'm going to show you something that's wrong. So don't do this. Just watch for a minute and just hang in there. So what if I had said same equation? I want the area for this f of x being the negative, and we're just going to go ahead and multiply this out. All right. But I want it between -6 and 0. So if you have not written this part down, that is the key to being correct, which is as soon as they say area, you must graph it and determine where it's above and below the x-axis. Then I'm going to show you why this becomes a problem. All right. So if you accidentally do this incorrectly and you go, okay, yeah, sure, I can do that. I just integrate from -6 to 0, and I'd have x squared plus 7x plus 10. And I didn't graph it because I didn't see the need and it was not in my list. So I'm going to pull this negative out, right? And when you do this, you would still have your x cubed over 3, 7x squared over 2, plus 10x from -6 to 0. All right. And when you do the math on this, all right, you would still have that negative. You would still put the 0 in. And then you would subtract. And you would get, now all of this goes to 0. So then you would have the negative of, and you have 0 from the front piece, plus 72 minus 126 plus 60. And this turns out to be the negative of 6. Now, remember what I said? If you get a negative when they've asked you for the area, not just to straight integrate it, but to find the area, if they use that phrase, okay, find the area, then you go, whoops, something's wrong. All right. So now look, if you go back to the drawing and you look at -6 here and 0 here, this section right here is going to come up as a negative area. And this section right here is a negative area. And this section right here is a positive area. So when you straight integrate from -6 to 0, you in effect find a net area. like if you had profits and losses, if this was your profit and the other thing was your losses, you'd be looking at your net. Okay. So um, so do you see how this negative section seemed to cover more area than the positive does? That's why this ended up being -6. So that says the net is I have more negative than I have positive, right? But it's not a total, right? They've You canceled the positive area into the negative, have -6 square units down below still, all right? So keep that thought in mind. Do not just straight integrate it unless you can tell from the graph that these contain only positives, all right? You could also do that if it was negatives. Just remember to change this plus or minus sign. Now, sometimes they don't use the interval like this. They'll say find the area between this curve, the x-axis, x is equal to -5, and x is equal to -2. So you would say, okay, I need x is -5, x is -2, this curve in the x-axis. So you look for something that is completely contained and say that's the section I want. All right. So there's different ways to say it. But the gist is, once they say anything that implies the area, you have to graph it, right? So if I really wanted to find the area, let me go way down here. Well, let's just scooch in here. So look right here. If I really wanted to find the area from -6 to -5, this section's negative. From -5 to -2, this section's positive. And from -2 to 0, this section is negative. All right, so I'm going to have to do 3 sections, a negative, a positive, and a negative. All right, so what I would do to be correct, same problem. And I want to find the area between that curve of the x-axis and -6 to 0. Then what I would say is, okay, between -6 and -5, I'm going to get a negative result because it's below the x-axis. So in order to turn it positive so it doesn't cancel out part of the upper area, I throw another negative in. So this negative is because my area is going to be negative. I can tell from the graph. Some of your teachers will not have you use a negative. They will tell you to do the absolute value from -6 to -5 of this mess. Okay, it's kind of messy. All right. So I was not taught that way, and I don't actually care for it because to me it's just too many symbols just make my brain kind of like slow down to a grinding halt. Okay, so but you do whatever your teacher models for you, and you do whatever makes you feel better. If you feel better using the absolute values, go for it. All right, so I would have, yeah, this is where it gets crazy. All right, this negative is because I'm trying to compensate for the fact that it's going to compute a negative area. All right. This negative is the negative that was given to me. All right. Now, between -5 and -2, it's going to give me a positive area. So that's good. I need a positive area value so I know how much carpet to go buy or how much paint to buy. So I'd still have the negative that goes with the equation. Right. And then when it went on the other side of -2, so between -2 and 0, it dips down below the x-axis. So that's going to give me negative y values. That would be a negative height. That's going to give me a negative area. All right. So from -2 to 0, Now remember, the negative that you see right now is the one from the formula. I'm going to put in another negative to negate the fact that I'm going to compute a negative area because the y values are negative. All right. Now, I know that you can do this all sorts of fast ways, but I'm going to kind of slow this down so that you can, I think if you can see how these negative signs are affecting your answer, it'll help your brain to kind of come to terms with what we're asking it to do. This is going to take up a lot of space. All right. So we have this negative, right? And then we know that when we integrate this, we've been doing this for a while. So we would have, now, up until this point, I took this negative out, but because I want you to see the effect of the red negative, I'm going to leave this negative in here and use it while I integrate. So I'd have negative x cubed over 3, because this is a square. It looks like a 7. Okay, minus 7x squared over 2 minus 10x. And I'm going to integrate it from minus 6 to negative 5. Now, you'll have noticed that, sometimes I use square brackets, sometimes I use round, sometimes I use this little upright line, sometimes it's part of the, especially if it's squared off like this, it's part of the bracket on it. Different teachers swing back and forth between different things. Again, model what your teacher is wanting you to do, all right? Then I would have the plus, and I would have the same thing. I would have negative x cubed over 3 minus 7x squared over 2 minus 10x. And this time I'm going to go from negative 5 to negative 2. And then I'm going to have this negative of this negative x cubed over 3 minus 7x squared over 2 minus 10x from negative 2 to 0. So as you can imagine, this is going to get crazy. So here's negative. And you would have the negative of negative 5 cubed over 3 minus 7 times negative 5 squared over 2 minus 10 times negative 5. Now that's this one part minus, and then you would have the negative of negative 6 cubed over 3 minus 7 times negative 6 squared over 2 minus 10 times negative 6. And that's just that one part. Okay. Plus, all right. So then you would put in the negative of negative 2 cubed. I'm trying really hard not to lose a sign myself. Minus 7 times negative 2 squared over 2 minus 10 times negative 2. Your teachers are also concentrating really hard when they're doing this. All right. Because we're all like, oh, don't let me do it wrong in front of the students. Minus a negative 5 cubed over 3 minus 7 times negative 5 squared over 2 minus 10 times negative 5. And I'm going to go back and check all these once I write this down. Minus. All right. Okay, 0. So you have negative, let me put this in here. Negative 0 cubed over 3 minus 7 times 0 squared over 2 minus 10 times 0. Now remember, not everything that's 0 turns out to be 0. Like if you have 2 to the 0, 2 to the 0 is 1. So don't just assume everything's going to be 0. Minus. Then you would have the negative, and you would have negative 2 cubed over 3 minus 7 times negative 2 squared over 2 minus 10 times negative 2. All right. There you go. Crazy, huh? All right. So this is the negative of, let's make sure I put these in the right. So negative 5 cubed, negative 5 squared, negative 5 minus negative. as I talk to myself. Right. It's good for you to talk to yourself as you, and really, truly, it's a good habit to get into, if, especially if these are complex, to write them all down while you try to concentrate and then go back and reread it and try to catch any errors that come up. Negative 2 squared. Okay, minus. All right. Now, be careful. Sometimes students will sit in here and go, okay, where's one? Like this one and this one. They'll say, oh, wait, those are a match. Maybe they'll cancel, but we've got signs going on here, plus and minuses signs. So hang in there. All right. So when you clean this up, and I'll skip a step here in a minute. Maybe not. All right. So you clean this up, plus 8/3 minus 28/2 plus 20 minus 125/3 plus 175/2 minus 50. And sometimes people will go, oh, look, here's a 50 and there's a minus 50. But look, if you follow this all the way out to the end, this isn't just a 50, it's a negative out here with the little red mark, right? So that's not going to happen. So be careful. Please don't try to shortcut corners. All right. And then we have the negative. And we would have 0 minus 8/3 plus 28/2 minus 20. And then when you get this kind of straightened up, right, you would have the negative of, this first one's going to be a negative 11/6 plus 9/2 minus a negative 26/3. So do you see, this is the first area. This was the negative area. This is the positive area. And this was the negative area again. So see how they do turn out with the pluses and minuses like what we expected, and the negative signs, or if you had wanted to use the absolute value signs, that would work out, right? And when you get this all cleaned up, it turns out to be 15, which makes sense, okay? It was a fairly, it was, whatever it was, 4.5, right? Just the positive section, the negative section looked bigger. So 15, that sounds reasonable. All right. Now, let's go over here and do this one. We're only going to do 2 of these. I've got some kind of more busy work problems for you to practice in the practice problems that are linked in the description. Okay. But once you catch the hang of it, which the key here is, do not just do straight integration from the beginning of the interval to the end unless you know it's all above the x-axis, all right? So if I want to find the area bound between this function and the x-axis, on the interval from 0 to 2 pi. As soon as you see this word, what is the one thing you have to do? You have to graph it, okay? So here's the sine function. You see its amplitude is 2, right? It's going to go up to 2, down to negative 2. Here's 0, here's 2 pi. And notice that this first section is positive, and this second section is a negative area because the y values are negative y values, and negative y times this base up here is going to be a negative area. So I have to compensate for that. So what I would say is this first section from 0 to pi is just fine. But the second section from pi to 2 pi is going to give me a negative numerical value. So I need to compensate for that by either using the absolute value signs or throwing another negative in there so that it changes the negative to a positive, right? So when you integrate it, you'd have negative 2 cosine x, because remember the derivative of cosine is a negative sign. And since this sign was not negative, it must have been negative cosine to start with. And you're going to integrate it from 0 to pi. Right, so this is this negative, and the integral is minus 2 cosine x integrated from pi to 2 pi. I have students who actually use colored pencils and color code it on tests and homework. And I just love it when they do that, because not only does it make it easier for me to grade, but if they can see it easier, then that probably means they're more likely to be correct, and it makes it easier for me to grade because their answer's more likely to be correct. So if their answer is more likely to be correct, I don't have to mark anything as wrong. I can follow along smoother. It's just a win-win situation all the way around, right? So I'm going to factor out the negative 2, and we're going to have cosine pi minus cosine of 0 minus, now this minus is this one. And I'm going to factor out the negative 2 and have cosine of 2 pi minus cosine of 0. So I would have negative 2, cosine of pi is negative 1, cosine of 0 is 1, okay, but then I have this subtraction sign is this one, okay, minus negative 2 okay, cosine of 2 pi is 1 minus, and cosine of 0 is 1. I'm sorry. This is supposed to be pi. Beg your pardon. That's fine. This is not what I expected. Okay, cosine of pi is negative 1. Okay, so it's negative 2 times negative 2 minus, all right, so then you would have negative 2 times a positive 2, because this is positive 2. So this is 4 plus 4, and this is 8. Now, are you surprised that these two numbers are the same value? You know, actually what is going on is that this one has an area of positive 4, and this one has an area technically of negative 4 because it's below the x-axis. But you can see that their absolute values are the same because it's symmetric, right? This curve, this sine curve is symmetric. All right, so it's not surprising that they're turning. So use the number and look at the number and ask yourself, does that make sense, right? Does it make sense? Is that right? First off, ask yourself if it's negative, because if it's negative, something's wrong. All right, I hope that helps. So remember, keep making lists, as you're studying. You're almost to the end. Actually, this is the end topic for most Calc 1 courses. And so this is in. Now all you have to do is put it all together. Remember all the lists that you've made all semester long for your final. And I'll have what is essentially a final review on the next video. And then you'll be through with your basic Calc 1 course. So be sure you have your list. Be sure the first thing on the list is, if you see area, graph it. All right. And I hope this helps. And next video, kind of a final review. And good luck.